surrounded by things that can make us sick all the time. That being said, our first line of defense is the innate immune system, which activates immediately upon infection to protect us from pathogens. This includes physical barriers like skin, mucosal barriers, and antibacterial secretions. When a pathogen breaks into our skin, the innate immune system is activated when pattern recognition receptors, or PRRs, recognize molecules that the body does not recognize itself. These non-self substances, called pathogen-associated molecular patterns, or PAMPs, are on the surfaces of foreign organisms like bacteria. Toll-like receptors, or TLRs, are a class of PRRs that are important to activating the innate immune system. Out of all the 10 TLRs humans can possess, I will be talking about the processes associated with TLR4. In the blood, a special type of white blood cell called the macrophage, with TLR4 embedded in its membrane, waits to encounter a foreign bacteria. TLR4 allows the macrophage to recognize a gram-negative bacterial wall component called liposaccharide, or LPS, which can become detached during an infection. TLR4 activation begins when LPS binding protein picks up LPS from the blood and passes it to another protein called CD14. CD14, present on the surface of the macrophage, transfers and loads LPS into the ectodomain, which is a curved domain of TLR4 that extends into the space outside of the cell. An accessory protein called MG2 allows TLR4 to recognize the LPS, and once a complex is made of TLR4, MG2, and CD14, another TLR4 molecule is added, creating a dimer. These two TLR4s coming together also brings together the toll-IL-1 receptor, or TIR domains, inside of the cell. The TIR of this complex will then interact with the TIR of signaling proteins such as MyD88. This will lead to the activation of several different signal cascades to initiate the production of special signaling proteins called chemokines and cytokines that will ultimately lead to an inflammatory response against the foreign pathogen.